In this example, the question says 5 grams of magnesium is reacted with excess hydrochloric acid as follows. Then we are given the reaction magnesium plus HCl for magnesium chloride plus hydrogen gas. Calculate number of moles of hydrochloric acid that reacted with HCl. So what we need to do here, we need to follow these steps. Step number 1 is to write the mole ratio. So let's write down the mole ratio. Our mole ratio is 1:2:1:1. So 1:2:1:1. So it means magnesium is reacting in the ratio 1:2 with hydrochloric acid, and it is in the ratio 1:1 with magnesium chloride, 1:1 with oxygen, with the hydrogen. Then from there, you go to the next step. You use one of the species to find the number of moles that have been used. So in this case, we use magnesium. Magnesium, we're given mass of magnesium and we know its molar mass. So if we have those two, it can help us to find the initial number of moles, and those number of moles that we can get will help us to find all the number of moles of all the species in the reaction. Okay, so in this case, we need to calculate the number of moles of magnesium. This is equal to mass over molar mass. Our mass, which is 5 grams over 24, which is its molar mass, then we get 0.21 moles. But the question is asking calculate number of moles of hydrochloric acid that reacted with HCl. Then step number 3, now we find the new ratio. Write down the new ratio. So for the new ratio, we multiply each number with the number of moles. So in this case, 1 times 0.21 gets 0.21. So these are number of moles of magnesium. Then for hydrochloric acid, it's 2 times 0.21, we get 0.42. As to 0.21 is to 0.21. So from analysis, you can see these two is the number of moles for hydrochloric acid, which is these ones. These are the number of moles that have reacted. So number of moles of HCl is equal to 0.42 moles. If they ask you number of moles of hydrogen gas, it's 0.21. Number of moles of magnesium chloride produced, it's 0.21. Example 2. 200 cubic centimeters of 0.01 mole per cubic decimeter of hydrochloric acid is required to neutralize 2 cubic decimeter sodium hydroxide of unknown concentration. Then we are given the equation sodium hydroxide plus HCl plus sodium chloride to form water. So the question is calculate the concentration of sodium hydroxide to be neutralized by 200 cubic centimeters 0.01 hydrochloric acid. Okay. Calculate the concentration of sodium hydroxide to be neutralized. So what you need to do here, first step, you write the mole ratio. The ratio 1:1:1:1. Or before that, you check if your equation is balanced. We have one sodium, so sodiums are balanced, oxygen 1, 1, balanced, hydrogen 1, 2, that side 2, so it's balanced. Then chlorine 1, 1. So our equation is balanced, and it is in the ratio 1:1:1:1. So first thing that we need to do, we use one of the species which have enough information to help us find the initial number of moles. So in this case, we are given 200 cubic centimeters of hydrochloric acid and its concentration. So with this data, it is enough for us to calculate the number of moles. So number of moles of HCl is equal to concentration times volume. Our concentration is 0,1 or 0,01 multiplied by our volume. It's 200 cubic centimeters. But we need to convert it to cubic decimeter by dividing by 1000. Then we get 0,2. Then our answer, we get 0,002. moles. So now we need to write the new ratio. New ratio is now 0,002 s to 0,002 s to 0,002 0,002. So now I want to calculate number of moles of the concentration of sodium hydroxide to be neutralized. But according to the mole ratio, it shows us that number of moles of hydrochloric acid is equal to number of moles of sodium hydroxide, because it's 0,2, 0,002, 0,002, which is these two species. So now number of moles of sodium hydroxide is equal to 0,002 moles. Then, as we want to calculate the concentration of sodium hydroxide, so what we need to do here, we use the formula concentration is equal to number of moles over volume. Our number of moles being 0,002 over the volume. How many cubic decimeters of sodium hydroxide to be neutralized, which is this 2. So we divide by 2. Then our answer will be 0,001 mole per cubic decimeter.